And on the notes for today, you notice how I left like a page for each problem because we'll do some triangle sketches and there's a whole lot of stuff to work out on the side. So, all right. So the last time we left off, we were going down that formula sheet. We had taken a look at the fundamental identities. We've taken a look at the sine, the sum and difference of cosine, tangent, and sine. Let me just pull up the formula sheet. That'll help me better. All right, so on this all exam formula sheet, we're basically going down this formula sheet. We talked about all of these formulas. Today, we're going to talk about the double number identities. We're going to talk about the half number identities. And then in the last section, we're going to talk about these product to sum and sum to product. Even though they look complicated, the only thing we have to do is look for patterns. All right. So we'll see how that works when we get to these two particular blocks of formulas. Today we're going to talk about the double number identities, and these are read as the double number for cosine. And you'll notice that there's actually three formulas to choose from. There is a double angle for sine and a double angle for tangent. I'm going to go back to the notes for today, and on the very first page, okay, even though it's not a proof course, this is how some of these formulas are derived. For example, the formula for the double number for cosine. So if you take cosine 2a, and you can rewrite 2a as a plus a, right? And we saw in the last time, this is the setup for a sum of cosine formula. And so in that sum of cosine formula, they simply substituted a for a and then b for a. So it works out to be cosine a times cosine a minus sine a times cosine a. And that pops out the very first formula. The double angle for cosine is equal to cosine square a minus sine square a, right? And that comes from the sum of cosine formula. But then you're going to notice there's two more formulas. This next formula is simply derived from the fact that you can rewrite cosine square a as 1 minus sine square a, right, from those Pythagorean identities. So I'm going to pull that up real quick. So right here, you can write sine square a as 1 minus cosine square a. You can write cosine square a as 1 minus sine square a. So in this first formula, they simply rewritten cosine square a as 1 minus sine square a minus another sine square a, and that's where this formula pops up, 1 minus sine square a. And for the next formula, they just did the opposite. They took sine square a and they rewritten as 1 minus cosine square a. Substituted it here, and out pops the next formula. It doesn't really matter which formula you use. In order to use the first formula, you must know both the sine and the cosine, if those values are handy. If you want to use the second formula, the only value you need to know is the sine. And if you wanted to use this third formula, the only value you need to know is the cosine. But no matter which formula you use, they should all give you the same result. We only have one number for the double number of sine, and that's equal to 2 times sine A cosine A. And that's found much the same way as this. You can write sine of 2A as sine of A plus A, and that would be the sum of sine formula. If you work that out, you get 2 sine A cosine A. And then the last one is the double angle for tangent. So if you were to write the tangent of 2A as tangent of A plus A, if you were to follow that sum of tangent formula, then out would pop this double angle for tangent. So now we don't really prove these formulas in the class, we just use them as givens. We're going to use these formulas to evaluate trig functions. All right. And they can also be used to simplify. All right. Trig expressions. All right, so how do you use them? All right, well, in the very first example, right, we're going to do what's called a triangle sketch. And this doesn't want to stay on the screen for whatever reason. All right, so this says find the exact values of sine of 2x, or the double angle for sine, the double angle for cosine, and the double angle for tangent. It says without solving for x. If sine of x is equal to negative 1/4 and x is in the fourth quadrant, we want to find this double angle for sine, double angle for cosine, and a double angle for tangent based on this given information. So the first thing I'm going to do is just sketch this out. My angle is in the fourth quadrant. Right, so remember, all of our angles are in standard position. I'm just going to arbitrarily place a point in my fourth quadrant. Right, and through that point, I'm going to draw my terminal side. So that's an angle in the fourth quadrant. I'm going to drop my perpendicular. And then we have X, Y, and R. So the only thing I need to do is if I can find out X, Y, and R, I can use that to find these double angle measures. Right. So that's the first thing. I just sketched out an angle in the fourth quadrant, and I'm given, so this was actually my angle right here. And they give us the fact that the sine of X is equal to negative 1/4, right? Okay, so that was all of the given information. Okay, this thing just keeps moving. So first thing, I just sketched that out. All right, we're going to add more to this in just a second. But the first part of this says find the sine of 2x, or the double angle for sine. First thing that I'm going to do is I'm going to look at the formula. The formula says if we want to find the double angle for sine, that's equal to 2, and they're changing the variable from a to x. It would be 2 sine x times cosine x. So I'm going to write that down. 2 sine x times cosine x. So in the problem, they give us the value for sine, right? The sine of x is equal to negative 1/4. So I'm just going to jot that in. So it's 2 times negative 1/4. So the only thing I need to do is I need to find the cosine for x. And if I can find the cosine for x, I can just multiply all that out, and that would give me my double angle for sine. All right, so everybody see where I'm heading. They gave us the sine of x. I just rewrote the formula. I have to find the cosine of x. So now I'm going to go back over here to the triangle sketch. And let's see if we can find the cosine. So remember, in the sine, just write these down again. The cosine of some angle is x over r. The sine of some angle is y over x. And the tangent of some angle is, the sine is y over r. And the tangent is y over x. And remember that r is always positive. So if you're dealing with a negative trig value, that negative has to go in the numerator. So they gave us the sine of x is equal to -1/4. So from my relationships, the sine is y over r. So that would mean that y is -1 and r has to be 4. So I'm going to jot that in. So y is -1. And I can see y is -1 because if this is an ordered pair, I would start at my origin. I would go over to the right, which would be a positive value, and then I would go down 1 unit. And r, remember that r is always positive, r is 4. So, excuse me, in order to find the cosine value, we need x over r. So remember, there were some Pythagorean formulas. R is equal to the square root of x squared plus y squared, right? You would use that if you wanted to find r. X is equal to the square root of r squared minus y squared, and you would use that to find x. Y is equal to the square root of r squared minus x squared. So the only thing we need to find for our triangle sketch is x, right? So once I know x, I can put x over r. That would give us the cosine value, and then that would allow us to evaluate this trig function. So we're going to find x. So I'm going to use that Pythagorean theorem. X is equal to the square root of r squared minus y squared. We know that r is equal to 4. Y is equal to -1. So x is going to equal to 4 squared minus, because that's a part of my Pythagorean theorem. Y is also a -1, so I must make sure I substitute in a -1. So x is going to equal to, 4 squared is 16. I'm going to bring down that minus because that's a part of my Pythagorean theorem. And if you square a -1, it brings back a +1. So then I have x is equal to the square root of 15. Since we can't simplify the square root of 15, we're going to leave it as the square root of 15. So now we have x, y, and r. So based on the values that we have, what is the cosine? Well, the cosine is going to be the x value, which we just found is the square root of 15, divided by the r value of 4. So we have the square root of 15 over 4. Right. So we found x, right? We had x is the square root of 15. And then we find the cosine of x. So the cosine of x is equal to x over r. So x is the square root of 15, and r is equal to 4. So this is where the square root of 15 over 4 comes in as the cosine value. So we made a triangle sketch in the fourth quadrant. We took the given information. The sine of x is equal to negative 1/4. Y was negative 1. R was 4. We substituted in those values. We found x using the Pythagorean theorem. And then we're able to find the cosine by just sticking that x value over r. So now we're just going to multiply them all together. Oops. So I'm going to treat 2 as a fraction. I'm just going to make that 2 over 1. A positive times a negative is a negative, and a negative times a positive is a positive. Excuse me, is a negative. 2 times 1 is 2. 2 times square root of 15 is 2 square root of 15. And if I multiply my denominators, 1 times 4 is 4. 4 times 4 is 16. So now if I reduce, my number is still negative. What's going to happen to the 2 over 16? Well, I can reduce both of those by 2. 2 divided by 2 is 1, and then 16 divided by 2 is 8. So the double angle for sine value should be negative square root of 15 over 8. So I'm going to try to put all of that together. So any questions about the double angle for sine? So now I'm going to do the same thing for the double angle for cosine. I'm going to write out the formula. So we're going to find the cosine of 2x. And the cosine of 2x from our formula says it is. Now we got a choice. Doesn't matter which one you use. Since I know both the sine and the cosine value, I'm going to use this first one. The cosine of 2a is equal to cosine squared a minus sine squared, or in this case, it's going to be x because our variable is x, minus sine squared x. So in this formula, we're going to substitute cosine x for square root of 15 over 4. We're going to substitute the sine of x in as negative 1/4. So I'm still using those same values from our triangle sketch. So notice now, I didn't write cosine squared, I just wrote cosine. When we square it, we simply take that cosine value, the square root of 15 over 4, and we're going to square that. Now that gives us cosine squared. Minus the sine is negative 1/4 squared. And now we're just going to simplify. So remember from algebra, when you, I think it's the square, this is what the formula looks like. It says a over b to the nth power. That's equal to a to the nth power divided by b to the nth power. So I have to raise my numerator and my denominator to my desired power. So going back to our fractions, I have to square both the square root of 15 and the 4. So when you square the square root of 15, the square root and the square, they do what to each other? Cancel. So that's 15. I also have to square the denominator, right? So 4 squared is 16. I'm going to bring down my minus. Now, when I squared negative 1/4, I have to square everything. I have to square the negative. So a negative times a negative is going to bring back a positive. I have to square the numerator. So 1 squared is 1. Oops. And I have to square the denominator. So 4 squared is 16, right? So now when we subtract fractions, we must have a common denominator. Since we have a common denominator, we're going to keep that common denominator. And we're going to combine the numerators. So 15 minus 1 is 14. And 14 over 16, I believe that's going to reduce to 7 over 8. So the double angle for cosine value is 7 over 8. All right, any questions about those two? So it's kind of all based on a little triangle sketch thing that you do. All right, now we're going to find the double angle for tangent. The tangent of 2x, and that should be the tangent. And if I look back at the formulas, it says the tangent of 2x is equal to 2 tangent A divided by 1 minus tangent square A. That's one possible formula. In the homework, I'm just going to bring that up. I think this is 2 point. Well, first of all, I need to get in the right class. 3.3. Okay, 3.3. They give another formula in the actual XYZ homework, which is a little bit more powerful formula. I should say more powerful. They're both the same. It's a little bit simpler to find. Okay, the tangent of 2x, remember that the tangent is just the sine over the cosine. So the tangent for 2x is going to equal to the sine of 2x over the cosine of 2x. So another possible formula you could use, I'm just going to jot that here, or I'll just put an equal sign. The sine of 2a divided by the cosine of 2a. So you got a choice on the tangent, but on the slides, they only list out one formula, and in XYZ, they list out the other formula. Right? But they're both the same, so no matter which one you use, you're going to get the same value. So now you can only use this formula if you know the double angle for sine and the double angle for cosine value. So the tangent of 2x, that's equal to the sine of 2x divided by the cosine of 2x. And we already found the sine of 2x, right? We found that in an earlier step. It was the very first solution, right? So the sine of 2x is negative square root of 15 over 8. So notice I'm not using this negative 1/4 deal because that's not the sine of 2x. That's simply the sine of x. The sine of 2x is negative square root of 15 over 8. So I'm going to put that in, negative square root of 15 over 8. I'm now going to put in the cosine of 2x. So we found the cosine of 2x, and we found that to be 7 over 8. And now I want to simplify. So remember the formula we were using, it says if A over B is equal, if A over B over C over D, then you can multiply the very top and the very bottom, and then the bottom of the top and the top of the bottom. So that means that I could multiply the very top and the very bottom. So a negative divided by a positive, that still keeps my number negative. When I multiply the square root of 15 times 8, the only thing I can really do is write that out as 8 times the square root of 15, right? And then I can multiply the bottom of the top and the top of the bottom. I mean, I could write that out as 8 times 7 is 56. But if I write it out in a factored form, I can now cancel some stuff, right? So I can cancel my 8s. So the double angle for tangent is negative square root of 15 over 7. All right, so any questions about the first one? And just be careful on the triangle sketch. All right, and then make sure for the tangent of 2x that you use those previous calculations, because if you were to use the formula, that might get a little bit time consuming. All right, the formula that's on the slide. All right, so any questions about the first one? All right, so pretty much going to do the same thing except for the next one. This is not in a coordinate system. It's just a triangle that's kind of hanging out in space. And then you have the two angle measures. I don't know why this thing just want to keep jumping to the very end. All right, so we have two angle measures. They give us alpha and they give us theta. So this is alpha and this is theta. Right, and they both are unknown angle measures. So you want to be careful on what they're asking you to find. Here they want us to find the double angle for the sine of alpha. So we got to make sure that we're using this alpha angle as our reference angle. Right? So I'm going to just write out the formula. So it says, first thing I'm going to do is find the double angle for 2 alpha. So the sine of 2 alpha, that equals to 2. So if I go back to my formula, 2 times the sine of alpha, and I'm changing my variables, times the cosine of alpha. So 2 times the sine of alpha times the cosine of alpha. So in order to complete this, we need to know what's the sine of alpha and what's the cosine of alpha. Since this is just a triangle that's hanging out in space, remember the chief Sakatoa, Oscar had a heap of apples. One old hippie called another old, some old hippie called another old hippie tripping on F's, that kind of stuff. All right. So we're going to have to set up a trig function. So in order to set up the trig function, the next thing we're going to do is label all sides according to the reference angle. So here we're using the alpha angle as our reference angle. So this is our reference angle. So I'm going to label my opposites, adjacents, and the hypotenuse according to this reference angle. So the first thing is let's list out the hypotenuse. So remember that the hypotenuse is always opposite the right angle. So this diagonal serves as the hypotenuse. Next, I want to list out my opposite. Since the side length 16 is opposite my angle alpha, which is my reference angle, this side serves as the opposite. And then the length 12 side, it shares a common side with my angle alpha, so this is the adjacent side. So now if I want to find the sine, remember the chief Sakatoa, the sine is the opposite, which we know, divided by the hypotenuse, which we don't know. But we can find the hypotenuse, right? If you're given two sides, you can find the third side by using the Pythagorean theorem. So the hypotenuse is equal to the sum of the legs squared So the hypotenuse is going to equal to the square root of 12 squared plus 16 squared. So notice my form for the hypotenuse is changing up. Before it was like x squared plus y squared. That's because it was in a rectangular coordinate system. Here, this is just a triangle that's hanging out in space. So the Pythagorean theorem, I'm just going to use is the hypotenuse is equal to the square root of the leg squared plus the other leg squared. So 12 squared is 144. 16 squared is 256. If we add 144 plus 256, I believe we get 400. And the square root of 400 is perfectly 20. So the hypotenuse is 20 units long. So now we got everything we need. We got the adjacent, the opposite, and the hypotenuse. So what is the value for sine? Well, 3, use chief Sakatoa. So the sine is going to equal to the opposite over the hypotenuse. So the opposite is 16, the hypotenuse is 20. We just slide this over just a little bit. So the sine is 16 over 20. And I believe we can reduce that, right? We can divide by 4. So that's like 4/5. We also need the cosine. So from Chief Sakatora, the cosine is the adjacent over the hypotenuse. So our adjacent side is 12. I'm sorry, this should be alpha. The hypotenuse is 20. And I believe you can divide both of those by 4. So that would give us 3/5. So now I'm just going to substitute those values into the formula and simplify. So this is 2 times the sine of x, which is 4/5, times the cosine of x, which is 3/5. We can write 2 as a fraction. We can multiply all of the numerators. So 2 times 4 is 8. 8 times 3 is 24. We can multiply all of the denominators. So 1 times 5 is 5, times another 5 is 25. And that should be the value for the double angle of sine. So here, no triangle sketch. The triangle was given, okay, but we had to find all 3 sides, right? And then just set up our trig function. So next, we're going to find the double angle for cosine. So let's find the cosine of 2 alpha. So now you have a choice of formulas to use, but I'm just going to stick to the cosine square alpha minus sine square alpha. So in this formula, we're going to substitute in the cosine as we found that to be 3/5. We're going to substitute in the sine of alpha as 4/5 and simplify. All right, so we're going to take the cosine value, which is 3/5. We're going to square that. Minus, we're going to take the sine value of 4/5, and we're going to square that as well. So remember, you have to square both the numerator and the denominator. So 3/5 squared, I believe that gives us 9/25 minus, because that's a part of our formula. 4/5 squared is 16/25. When you subtract fractions, you must have a common denominator. We have a common denominator of 25, so we're going to keep that common denominator, and we're going to combine the numerators. So 9 minus 16 is -7/25. And that is the value for the double angle of cosine. And then lastly, we want to find the double angle for tangent. So we're going to use the tangent of 2 alpha is the sine of 2 alpha divided by the cosine of 2 alpha. So we're going to use the calculations from the previous steps. So we found the double angle for the sine of alpha was 24 over 25. We just found the double angle for the cosine of alpha was -7 over 25. It's -7 over 25. So a positive divided by a negative gives us a negative. I'm going to multiply the very top and the very bottom. So notice when I say multiply, I'm really just writing it out in a multiplicative form without multiplying, just writing it out in factors. So I'm going to write that out as 24 times 25. I can multiply the bottom of the top and the top of the bottom. So I'm just going to write it out in a factor form, 25 times 7. And the reason why I'm writing them out in factor forms is because you will get some cancellation. So we have -24 over 7 is the double angle for tangent, which is the simplest version of this formula to use. All right, so any questions about the double angle identities? Right. So the only thing you got to sketch out a triangle, kind of, maybe find x, y, r, right? Then just substitute those values into the formula. We're going to do much the same with the half number identities. Now these can get kind of sticky a little bit. All right, so here again, this is not a proof course or anything, but this is just how the formula is derived. So the half number identities, they come from the double number identities. So what's going on here is this equation is, first of all, they took the double angle for cosine and they subtracted 1 from both sides. And then they divided both sides by a -1. And then they like flipped it around. So you get 2 sine squared x minus 2 sine squared x is equal to 1 minus cosine squared x. And then they divided both sides by 2. And then they use the square root property. The square root property says if a squared is equal to c, you square both sides, and the side that's not squared has to sprout this plus or minus. And then they kind of played a trick. They substituted 2x for a. So notice in this form is the cosine of a. So if we substitute 2x for a, that will allow us to rewrite x. Like if you were to solve this for x, you would divide both sides by 2. So x is equal to a divided by 2. So then they substituted x for a over 2. You're going to notice this plus or minus in some of these formulas. So I'm going to go down. So notice that like these first 3 formulas have a plus or a minus. The first thing that you must do is determine which quadrant your angle lies in. And then remember this all student take courses deal. Once you find out which angle your quadrant lies in, then you can determine if it's supposed to be negative or positive. So it's like for these first 3, you got to kind of figure them out. But in these last 2 for tangent, notice they don't come with a plus or a minus. Whenever you substitute in those values, the plus or the minus will come out when you substitute. But be mindful that these formulas, especially the cosine and the sine, they carry a plus or a minus. So we're going to see how that works. Okay. So now, just as in the double number identities, these half number identities, they're used to simplify trig expressions and also to evaluate trig functions. All right, so the Half angle for cosine says that it's plus or minus the square root of 1 plus cosine A divided by 2. The half angle for sine is really the same. Instead of being plus cosine, it's minus cosine A over 2. And then for the tangent, the half angle for tangent is 1 minus cosine A divided by 1 plus cosine A. I would try to stay away from this one as much as possible, because you got a square root, and then you might have a fraction at the top and a fraction at the bottom. Okay. These two, notice that they don't come with a sign. The sign comes out when you simplify, but you must know the sine and the cosine. So even though this first one, you only need the cosine value, it's a little bit more work than the other two. But no matter which formula you use, you should get the same final answer. All right, so let's see how these half angle formulas work. All right, so this is the next one. I don't know what number this is in the homework, but it says find the exact value using the half angle formulas. And I mentioned this earlier. If they're telling you to use a certain formula, use that certain formula. Because let's say you could probably use a sum and difference, but if you use a sum and difference, the numerical answer gonna look totally different. So you'll kind of see once you do these homework problems, hey, I answered the same question in section 3.1, but the answers look like totally different. That's because the formulas that you're using make the answers look different, but numerically it's the same value. So here we want to find the exact value for the cosine of pi over 12. So the first thing I would do is just take this out of radian mode and write it in degree measure. So the cosine of pi over 12, remember that pi is 180 degrees. So I'm simply going to multiply divide 180 by 12. Right, because pi radians is 180 degrees. I divide that by 12 and we get 15 degrees. And you probably answered this in section 3.1, and you probably used the difference of cosine, like the 45 minus 30, and you got to answer that way. And that will be the correct answer. But if you're using these half angle formulas, the answer is going to look totally different. So now how do I use the half angle? So more so like we did the add and subtract, and if you can find an angle that you can add or subtract. Here, since I'm using a half angle, if I can find half of my angle, or half of what angle is 15? 30, right? So I can rewrite the cosine of 15 degrees as the cosine of 30 degrees divided by 2. Because 30 divided by 2 is 15. This allows me to use this half angle formula. Right. So notice before you had to add or subtract. For the half angle identities, you want to find an angle that you can split in half to give you your desired value. Right? So we're using the cosine of 30 divided by 2. So therefore, I'm going to use this half angle for cosine formula. So I'm going to just write the formula right above the problem. So it says the cosine of A over 2, that's equal to plus or minus times the square root of 1 plus cosine A over 2. So in this formula, wherever I see an A, I'm going to substitute that for 30 degrees. But first, I need to take care of this plus or minus. So I'm finding the value for a 15-degree angle. I don't want to deal with this angle right here because I'm actually trying to find a cosine of 15 degrees. What quadrant is 15 degree in? The first one. If you're in the first quadrant, is the cosine positive or is it negative? Well, if you're in the first quadrant, all 6 trig functions are positive, so I'm going to use positive. So that's the first thing. You got to establish where your angle is, and then you can use the all student take courses to find out if it's positive or if it's negative. Right? So I know it's positive because 15 degrees is in the first quadrant, and the cosine values in the first quadrant are positive. Right? So establish your sign. Okay, so now we have the square root of 1 plus the cosine of A. So remember that A is 30 degrees divided by 2. So now the only thing I have to do is find out what's the value of the cosine of 30 degrees and then simplify. All right, so I thought they would give it to us. I'm just going to pull up the function values 3.2. I don't know why they didn't put these in section 3.3. All right, but I'm just going to pull this up to find out the cosine of 30 degrees. So here is 30 degrees. The cosine value is square root of 3 over 2. So I'm going to substitute. So it's understood to be positive. So I'm just going to drop off that positive sign. 1 plus the square root of 3 over 2 divided by 2. I wonder if it'll take that for an answer. Well, it won't. Okay. We got to simplify it some. I know sometimes it's good about the radicals and then. Okay. So how would we simplify this? Right. Okay, remember from the last, when we were dealing with that double angle for tangent, I want to multiply by a special count of 1. Just put another step in. I want to multiply that by a special count of 1. It'll be 2, right? Because remember, we had to find the least common denominator for all of our terms. So this 1 has a denominator of 1, and the 1s don't count as far as the least common denominator. The 2 in the denominator had a denominator of 1, but this square root of 3 had a denominator of 2. So I want to multiply the numerator and the denominator by 2. So remember, anything over itself is 1, and anytime you multiply something by 1, you don't change the value, but you can change the way that your number is expressed. So we're going to multiply by 2 over 2. The next thing is you want to remember to distribute. All right, so this is still under the square root. So 2 times 1 is 2. Square root of 3 divided by 2 times 2. Those 2's are going to do what? Cancel. So I'm left with the square root of 3. And then 2 times 2 is what? 4. Is everybody okay with that point? Okay, now there's another rule from algebra that says you can, this is what the formula says, the nth root of a divided by b, that's equal to the nth root of a divided by the nth root of b. So that means I can rewrite this fraction with a separate square root for the numerator and the denominator. So I can write this as the square root of 2 plus the square root of 3 divided by the square root of 4. And the denominator is perfectly what? 2. So this will be my final answer. 2 plus the square root of 3 divided by 2. And that's the only reason why I took the square root of the top and the bottom, was because the bottom was a perfect square. So now I want to show you, say, is everybody okay with the answer? So let's just say you're working this out and we go back to the right set. You put your answer in and it says that the answer is incorrect. And then I believe it's going to give you the answer. Oh, it changed it up. Oh my goodness. Let's see if it'll give me that same problem back. It probably won't. Well, it was a cosine. It's probably never going to do it. Sometimes it'll change the answers up and then sometimes it won't. Okay, I'm going to do this a couple more times. Hopefully it's going to work. Maybe top 12. It might do it here. I'm just trying to show you. If you hit the view an example, it gives like a weirded out type. Here it is. Let me try something real quick. Because I want you to see the answer that it gives. Here it is. So notice that that's the answer that it gave. The square root of 1/2 plus 1 divided by 4 times the square root of 3. And then notice what my answer is. My answer is this. Numerically, these are the same. It will take this answer, though. I'm going to put it in. Well, before I put it in, I want to evaluate both of these answers. So I'm going to put this one in kind of slow. This is the square root of 1/2. So I'm just going to change that to 0.5 because 0.5 is 1/2. Plus, and I'm going to rewrite this 1/4 times the square root of 3. I'm going to rewrite that as the square root of 3. So I'm going to close off my square root, divided by 4. Close off my original square root, I get 0.9659. For my answer, I'm going to put this in. It's the square root of 2 plus the square root of 3. Close off the square root from 3. Close off the numerator, divided by 2. Those are the exact same answer value. One's just written differently from the other. So I show you that because let's just say if you're working a problem out and you don't get the problem right, and then you hit view an example, you say, hey, where did they get this answer from? You can get the same answer, just have to be simplified down a little bit further. But I just want to let you know that there is more than one way to write out the answer. So I'm going to put this in. I just hate putting in the square root stuff. So this is the square root of 2 plus because this is square root inside of a square root. The square root of 3 divided by 2. And notice they will give you credit for that, even though it's not what they have out to the side. So I'm telling you that because if you don't get this answer here, don't rack your brain doing it, because the people that write the answers for these questions are working on like their doctor's degree and they're trying to impress their instructors or whoever. So sometimes these answers that you see may be above and beyond. Any questions about this problem? So once again, once we substituted in the square root of 3 over 2 for the cosine of 30, we then found the denominator. The least common denominator was 2. We carefully multiplied the top and the bottom by 2. So if you have more than one term, you got to distribute. And then I used this rule to separate out the numerator and the denominator, only because the denominator is a perfect square. All right, so let's take a look at the next example. So they want us to use a half angle formula, so please make sure you stick to whatever their formulas that they're asking you to use. All right, so this is the tangent of negative 19 pi over 12. So the first thing I'm going to do, just like in the last example, I'm going to convert this to degree measure. So this is the tangent of negative 19 pi over 12. So I'm going to substitute pi for 180 degrees. So that's negative 19 times 180 divided by 12. And we get negative 285 degrees. So I'm running into some problems because what angle between 0 and 360 is no angle, right? That I can take half of, that'll give me 285. What could I do from this point? I can add 360 because I would have a coterminal angle, right? So I'm going to add 360. So that's the tangent of negative 285 plus 360. So if I add 360, we get 75 degrees. So a 75-degree angle and a negative 285 degree angle are exactly the same. So this becomes the tangent of 75 degrees. So is everybody okay with that part? We converted the radian to a degree, and then we added 360, we got 75. So now what angle can you cut in half and get 75? I'm gonna multiply by 2, so 75 times 2 is 150. So that means we can rewrite the tangent of 75 as the tangent of 150 divided by 2. Right? Because 150 divided by 2 is 75 degrees. So right above that, I'm going to write the formula. And we have some formulas to choose from, right? So if I go back to the formulas, where is it? That's too far back. This thing went back all the way to the beginning of the class. All right, so notice there were three formulas that we have to choose from. Here it is. All right, so there's three formulas to choose from. I would stay away from the first formula. I think I got too much stuff on one page. That's probably why I was acting crazy. I'm going to use this formula. Notice I don't have to determine a sign or anything. The sign is going to pop out in the mix. But you must know both the sine and the cosine, and we can find those using that function values chart. So I'm going to rewrite this as the sine of A divided by 1 plus the cosine of A. So that's equal to the sine of A divided by 1 minus the cosine of A. So in this formula, I'm going to substitute A for 150. Right, so this is equal to the sine of 150 degrees divided by 1 minus the cosine of 150 degrees. So if we look at our special angles chart, it looks like the sine of 150 degrees is 1/2, and the cosine is negative square root of 3 over 2. So I'm going to substitute those values in. So the sine is 1/2, and in the denominator have 1 minus, and the cosine of 150 degrees. Is that a minus or a plus? It's 1 plus cosine A. So that should be 1 plus cosine A. I thought something looked funny. So that's 1 plus, and then the cosine of 150 is negative square root of 3 over 2. So to simplify, we got to do what? Multiply by that special form of 1 again. So what's our least common denominator? Should be 2, right? So we're going to multiply I'll put another step in. We're going to multiply the top and the bottom by 2. So remember, we got to distribute in the denominator. All right. So 1/2 times 2, the 2's are going to do what? Cancel, and that's going to leave 1 in the numerator. You have to distribute in the denominator. So 2 times 1 is 2. A positive times a negative is a negative. Square root of 3 divided by 2 times 2, the 2's cancel, and we're left with the square root of 3. And I think it'll take this as an answer. Let me just check that out. Negative 19 power over 12. So notice when I hit, oh, and that's not the tangent. Okay, the tangent of ours was negative. Well, the same thing might happen. Like you might get a different answer, but just to simplify this a little bit further, just to show, I want to multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate of 2 minus the square root of 3 is 2 plus the square root of 3. And then if I multiply my numerators, 1 times 2 plus the square root of 3 is 2 plus the square root of 3. And for my denominators, a plus b times a minus b, that's equal to a squared minus b squared. So that's what I have in the denominator, sum and the difference. So I could substitute 2 for a. Right? So in each one of these things, 2 is a and b is square root of 3. So I can substitute a for 2, and we got to square that. Minus, I'm going to substitute b for the square root of 3, and we're going to square that. So 2 squared is 4. I'm going to bring down my minus. The square root and the square cancel. We get 3. So therefore, we get 1 in the denominator. So that final answer is 2 plus the square root of 3. So I believe they would take this one. All right, but to simplify that out, and this is probably what you're going to see if you hit the view and example. All right, so any questions about this one? So notice there's a lot of this stuff right here that's going on, simplifying these fractions. All right, now here is the last problem. And it's a triangle kind of hanging out in space again. So it says use the figure below to find the requested values. So here we have a triangle, right? We have two angle measures. There is theta and alpha. This time they want the half angle for the sine of theta, the cosine of theta, and the tangent of theta. So when we label our sides here, we're going to use theta as the reference angle. So we're pretty much going to do the same thing. The first thing I'm going to do is I'm going to find the half angle for the sine of theta. I'm just going to write out the formula. This half angle for the sine of theta, that's equal to, and I don't want to flip back through the notes because it might freeze up. So the half angle for sine, that is plus or minus the square root of 1 minus cosine theta over 2. Right. So what is the cosine of theta? Well, in order to find the cosine of theta, I'm going to label all of my sides. So this is basically that same triangle, and we found that R was 20, right? We got 12 squared plus 16 squared, that gave us 400. And once we took the square root, that gave us 20. The difference is I'm using the angle theta instead of alpha. So now that we label our sides, 20 is still the hypotenuse. Since the side length 12 is opposite our reference angle, 12 is now the opposite. And since the angle and 16 share the common side, 16 is now the adjacent. So you have to be careful on what your reference angle is. So now in order to find the cosine, remember the chief Sakatoa? The cosine is the adjacent over the hypotenuse, right? So our adjacent is 16, hypotenuse is 20. That reduces down to give us 4/5, right? So in the formula, I'm going to substitute the cosine of theta for 4/5. So now what about the sine? Is it positive or is it negative? Well, since this triangle is not in a coordinate system, this thing is going to have a positive value. The only time a positive or negative really matters if you're in an X and Y coordinate system. But if it's just a triangle that's kind of hanging out in space like this one, we're going to always go with positive. So we know that the sine is positive, and this is times the square root of 1 minus the cosine of theta, which is 4/5, divided by 2. So I'm going to put an extra step in. So what do we have to multiply by on this one? By 5, right? Because the only denominator is 5. This 2, even though it's in the denominator, if you write it as a fraction, it has a denominator of 1. Right? So our least common denominator is 5. So we're going to multiply by 5 over 5 again. So in the numerator, we have to distribute. So remember, this is all under the square root. So 1 times 5 is 5 minus 5 times 4/5. Those 5s are going to cancel. That's going to give us 4. And in the denominator, 2 times 5 is 10. So if we simplify the numerator, 5 minus 4 is 1. So that's the square root of 1 over 10. I could use the quotient rule for radicals and rewrite that as the square root of 1 over the square root of 10. And the square root of 1 is perfectly 1, so we get 1 over the square root of 10. But if you look at the answer choices, they probably won't have it written this way because you can go an extra step and rationalize the denominator. So rationalizing the denominator means to take any radicals out of the denominator. So just to go a step extra, I could multiply the top and the bottom by the square root of 10. So then I get something that looks like this, the square root of 10 over 10. Right? Because 1 times the square root of 10 is the square root of 10. The square root of 10 times the square root of 10 is the square root of 100. And the square root of 100 is perfectly 10. All right, so that's the half angle for sine. Next, we're going to find the half angle for cosine. So I'm going to write the formula. The cosine of theta over 2 is equal to, now it's going to be plus because it's just a triangle hanging out in space. So it's positive times 1 plus the cosine of theta over 2. And we've already found that cosine value, right? The cosine was 4/5. The cosine of theta is 4/5. So I'm going to substitute that in. 1 plus 4/5 all divided by 2. So the only difference in these two formulas is one has a minus cosine, and then the cosine formula has a plus cosine. So here again, the denominator is 5. So we're going to multiply the numerator and the denominator by 5/5. So remember, this is all still in the square root. So 1 times 5 is 5, plus 4/5 times 5. The 5's cancel. I'm left with 4. And 2 times 5 is 10. So we get 9/10. I can use the quotient rule for radicals. I can separate that out as the square root of 9 over the square root of 10. The square root of 9 is perfectly 3. So I get 3 over the square root of 10. They're going to accept that for an answer. But if you want to rationalize the denominator, I'm just going to multiply by a special form of 1, right? Anything over itself is 1. If I multiply straight across, 3 times the square root of 10 is 3 square root of 10. And the square root of 10 times the square root of 10 is 10. And then for the last one, okay, they use a different formula that's on the actual formula sheet, but the half angle for tangent over 2, that's equal to the half angle of sine divided by the half angle for cosine. So we've already found those values. The double angle for sine was square root of 10 over 10. The half angle for cosine was, I'm going to use 3 over the square root of 10. And now I can multiply the very top. So the square root of 10 times the square root of 10, that's going to give us 10, right? I'm going to write that out. The square root of 10 times the square root of 10. I can multiply the bottom of the top and the top of the bottom. That's 3 times 10. So I get 10 over 30, which is 1/3.